Hello everyone, this is poster 157. My name is Tayná Fiúza, and today I'm going to present the work entitled Immunogenic Promiscuity of Streptococcus Cas9 regions to HLA alleles common in South America. Many of you may know Cas9 as a CRISPR-associated protein 9, which is a powerful gene editing tool that has many possible clinical applications. However, one of the downsides of administering Cas9 in vivo is that it may lead to unwanted immune reactions originated either from previous exposure to Cas9 or Cas9 similar proteins, or by the repeated exposure to Cas9. Some studies have already considered this immunogenicity and proposed deimmunizing mutations considering two epitopes that bind to HLA-A0201, which is a quite frequent class 1 HLA allele. In this work, we decided to investigate the immunogenic promiscuity of Streptococcus pyogenes Cas9, that is, the number of distinct HLA alleles a peptide may strongly bind to, regarding HLAs that are frequent in South American countries. To explore the subject, we acquired an S pyogenes Cas9 sequence from a curated database, which is UniProt, and 27 HLA alleles frequent in South American countries from the supplementary table provided by Requena and collaborators. We used this as an input data for the peptide HLA binding affinity prediction softwares NetMHC Pen 4.1 and NetMHC2 Pen 4.0. With the output, we looked only at the predicted strong binders, which are defined as those peptide HLA pairs whose percentile ranks go below 0.5. The strong binder dataset was imported into RStudio, where we used R to run an exploratory analysis. There, we calculated the summed promiscuity for each residue in the S pyogenes sequence, that is, the count of different HLA alleles predicted to bind to peptides overlapping a position. After looking at the summarized data of residue-wise summed promiscuity, we understood that it would be interesting to also consider the different frequencies of HLA alleles in South America, as they are not equally distributed in the continent. So, we weighted the promiscuity scores using the allelic frequencies. The main results we're going to look at right now are the plots for the summed promiscuity and the normalized version of the summed weighted promiscuity for both HLA class 1 and 2 alleles. Figure 1 shows data related to class 1 immunogenic promiscuity. In A, we have the summed promiscuity plot, and in B, we have the weighted promiscuity plot. With the weights, we can see a shift in the rank order of the peak promiscuous residues. Those peak regions center around residues 1237, 1015, 597, and 99. For class 2, the first striking feature of this plot is that there are no strong binding peptide HLA pairs on the final quarter of the sequence. That's not to say there weren't any immunogenic peptides in those regions, it's just that they didn't reach the cutoff. Anyway, what we can see here is a shift similar to the one we saw in figure 1. If you consider the highest peak on figure 2b, around residue 111, and look back into the simple promiscuity plot, you'll notice that it was previously the third or fourth peak in order, with the promiscuity value equal to the peak around residue 933. Still, interesting regions for a class 2 guided deimmunization effort center around residues 933, 923, 555, and as I mentioned before, 111. To finish, we conclude that using a weighted promiscuity approach adds another dimension for the rational selection of regions for deimmunization efforts. These regions pointed in this work may be used in experiments of such type, and approaches similar to this one may be applied to other biotherapeutic proteins or for subunit vaccine pilot studies. Here are the main references, the first one regarding the prediction algorithms, the second one is a deimmunization effort for Cas9, and the third one is the one that provides the HLA frequencies. We'd like to acknowledge the support from different agencies. Ramiro and Yamil have the support from CONICET, and Gustavo and I have the financial support from CAPES. Thank you very much for watching this presentation. I'll happily take your questions. Here's my email and Twitter. Once again, thank you.